need to have my goggles on. Okay, what I'm going to do with the water, this jar contains a compound called sodium chloride. I imagine many of you recognize that name. Alright? It is simple table salt. What I'm going to do is put the salt, the sodium chloride, in the water, and what's going to happen? The salt gets wet. Sometimes you see it further, we need to give it a stir, but when I give it a stir, what's going to happen?
Dissolve.
It will dissolve. So the salt will go away, right? Hopefully, if I know how to stir this, right? Slowly. Mostly gone. It's gone, right?
Yeah.
Or is it still there?
Gone. Still there.
Still there. How will we prove it's still there? We can taste it. We'll taste the salt, right? As a laboratory technique that leaves something we desired. Right? We could also evaporate off the water, right? If we evaporate off the water, I'll get the salt back, right? In pretty much the same state it went in. I start out with white crystals, I'll get white crystals, right?
White crystals.
Now let's compare that to another dish of water.
Oh.
You don't have to do it off of this one. This one, I'm going to add something else. I'm going to add a metal to this one. If I can find my forceps. Here we go. Now this metal is a metal called potassium. It's stored under oil, so I'm going to wipe the oil off. And I'm going to put it in the water. Let's see what happens. Did that do something different from the sodium chloride?
Yeah.
If I were to evaporate the water, would I get my potassium back?
No.
No, I wouldn't. Right? So here's where chemistry really started historically. People noticed that things interacted differently. There were things that we called physical interactions, like the salt in the water,